Well, hello everyone, and thanks for joining me for the first episode of my podcast. In this episode, I hope to educate whoever's listening really on a pretty fairly regularly talked about technology and try and do that in a way that's easy for you to understand. And I think the whole reason that I want to do this podcast at all is actually to help myself learn a little bit more about different technology concepts. And the first one that we're going to talk about today is blockchain. And we're going to use Bitcoin as an example because if you've ever looked at different types of blockchain technologies, you'll know that each one of them tends to use different components to make up that blockchain. So different types of consensus algorithms, different types of technology are used with each. So Bitcoin is arguably the first one, so we use that as a starting point. So let's start this conversation by talking a little bit about why blockchain actually came about. For me, I found this quite a complex concept, complex system, and it involved a combination of a number of different technologies and processes in order to work. I really love technology, in particular the things that came out of advances from Web 2.0, the internet, social media, all of the different things that the internet has afforded us probably in the last 10 to 15 years have been the things that I've dreamt about as a kid. But the internet is good and bad. Some things are negative, some things are positive. You can email your pals on the other side of the world. You can find pretty much any information about any topic, and you can buy stuff. But all of this depends on a singular important component, and that is the component of trust. So is the person that's emailing you actually your friend? Is the information that you're reading verified as correct, or is it fake news? And when you buy stuff, can you be sure that the seller is who you're buying it from? And can the seller be sure that you're actually the buyer? Well, not really. I think that's something critical to take into account. We've architected some pretty rudimentary security measures to control the internet, control trade in particular, and make sure that we can rely on this to a certain extent. But ultimately, no one really knows, and this can be circumvented in a number of different ways. We see data breaches on a daily, hourly, if not seconds and minutes go by before another breach occurs on the internet. So this isn't so bad for things like email because a lot of the time this can be validated. You can see someone in person and say, "Did you send me that email?" Data can be fact checked, even though that's not such a great thing to rely on. But when it comes to something like a digital currency, basically, and before Bitcoin and before the blockchain, we just relied on money. We couldn't rely on digital coins because there was no way to trust that the person actually owned the digital token that they were trading, and there was no way to really stop them from double spending those tokens. But blockchain tries to solve that. The other thing that was needed in traditional forms of money or fiat currencies was a huge number of intermediaries, third parties such as central banks, banks themselves, traders of some shape or form to basically put the controls in place and activate a double ledger system of some type to track money and can protect it basically. I'm not going to go into the detail about how the monetary system might or might not need to be changed. There are sort of benefits in and of itself to move to a digital currency, but instead let's focus on the element of trust and why that's important. And we'll, as I say, use Bitcoin as an example. So there are two main points in relation to blockchain that I think are important for the everyday person to know, and that is, or those 2 points are, that it's a distributed database firstly. So unlike a centralized database, the aim of blockchain is to be distributed or decentralized, meaning that multiple copies of the ledger are held on multiple computers all over the network. So that way you can't just change a database entry in one place and then obviously commit some type of fraud and say, actually, rather than 5 Bitcoin, I have 500 Bitcoin. And we'll come back to that in a second. So distributed database. And the second point about Bitcoin or the blockchain, which is important to note, is that there is something that makes this secure. So even though it's on multiple computers, someone can't brute force attack all the computers in the network and change enough of them to give someone a higher balance of coins because of this element of consensus, and riding on that is the consensus protocol. So for me, this is the most difficult part to understand about blockchain in and of itself. And as I said at the very start, there are different types of consensus protocols that are in use, and the one that is in use for Bitcoin is proof of work. So this is basically how information goes from one state to another on this shared database, and how new information is accepted onto the ledger. So any of the computers on the blockchain can make a change, but only if they abide by the consensus protocol. So if a computer tries to make a change outside the bounds of the protocol, or if they try to change a transaction retrospectively, the network rejects the change. So when it comes to proof of work in relation to Bitcoin, a hash function called SHA-256 or SHA-256 explains how this works. So basically, you can put anything into this hash function and the result will be a 256-bit value. No matter what the information is that goes in, this 256-bit value comes out. So you could have hello 1 exclamation mark, throw this into this hash function, and out will pop a 256-bit value. And it's kind of like a fingerprint. And I say fingerprint because the information looks completely arbitrary, but it's not. Even if you change a single character in the information going into the SHA-256 hash function, the resulting value will be different. But if you put that information or data back through the SHA function, it will basically return the exact same result. And that's really important, because what that means is that it's easy to validate that someone has the correct 256-bit value or key. So if someone has the right version of the key, then they can make changes to the database, which is permeated through the rest of the distributed blockchain. And the only way for them to have got this key is to have used a massive amount of compute power to have run through different options through the hash function until they get the right key. But how was the key generated in the first place? Well, it was generated by running the entire history of the blockchain, and so all the entries before the current block, through the hash function, but with a single value different, which is called the nonce. So that way, all the blocks are effectively placed on top a long history of ledger entries, all the way back to the Genesis block. And the Genesis block is the one that was created by Satoshi Nakamoto, whoever he or she was, or group of people, meaning that even if a single character is different in the hash function, it's going to return a different value. So therefore, the consensus protocol will reject the change. So that's the underlying basis of proof of work. So just to go over that again, you effectively pump some data, which is the history of the blockchain, through this hash function. It spits out a resulting value, which is 256-bit value. And then after you have that value, you basically can prove that you were able to do this. But the thing is, so the nonce, you don't know the nonce, so that means that you have to go through all the different permutations of the hash function until you find the right one. And that way, by having all of this data on top of each other, it becomes irrefutable. So only one version of the blockchain can survive if there is some reason that there's a fork, which is where two people solve proof of work at the same time. And this is done after the proof of work is propagated across the network. So the way I've heard this described is like two stones being thrown into a pond. That ripple effect is how the proof of work sort of ripples throughout the distributed network, and then the person that solves the next block the quickest, depending on which fork they're on, that becomes the accepted fork. So it's all about whoever has the most compute power basically forces the distributed network to progress. Effectively, voting is done through this hashing power, at the end of which the shorter fork is abandoned and the next block is released. So doesn't this mean that you could change a block and then just effectively solve the next block before everyone else? Well, you could say change the database at block 2 or 3, but then you'd have to make the change to all of the following blocks up to the current block. Still going through that consensus protocol using huge amounts of compute power, and then you'd have to then solve the current block before anyone else does, all in under that 10-minute window. So to me that sounds pretty secure in the current day, at least, because we haven't got the sort of quantum computing that it would require in order to break the blockchain consensus algorithm, so to speak. So without going into further detail about the technology itself, we can reflect on that and think about how else the blockchain could be useful. So you could have digital tokens such as Bitcoin, Ethereum's Ether, Cardano's ADA. They're all definitely good examples of cryptocurrency, but there are a myriad of other things that might be useful to have on a blockchain as well, such as digital contracts, your health records, music distribution, smart voting, anything else that you can think of that you might want to ensure the validity of through the use of a distributed blockchain network. So that is Blockchain 101. I hope that is useful for you. The two concepts of the shared database and the consensus protocol are the two pieces of the puzzle that were most difficult for me to understand. In future podcasts, I'll talk about different cryptocurrencies as well, and different types of the consensus protocol, such as proof of stake, and we'll also explore some other technology concepts as well. So stay tuned for the next episode. Happy to receive any feedback on what you'd like to hear more about, what I should do more of, stop doing. Thanks a lot for listening, and yeah, speak to you soon.